In this video, we're going to be talking about our trigonometric functions or trig functions and some of their foundational topics. Those foundational topics include circles, the distance formula, and we're going to start things off with the Pythagorean theorem. Trigonometric functions are functions that relate the sides of triangles to the angles within a triangle. And they're used in all different sorts of applications. Particularly, they're used a lot in construction and surveying. So let's go ahead and dive right in with the Pythagorean theorem. I've got a right triangle here, and the right triangle has a 90-degree corner. So let me go ahead and grab a pen here. And then we'll go ahead and label that corner. And I want this to be just a little bit bigger. There we go. So I'm going to label that 90-degree corner. Here it is. So this is 90 degrees, or a square corner. The Pythagorean theorem relates the lengths of the sides together. So I've got two legs, lengths A and B, and then a hypotenuse. There's the hypotenuse word spelled out there, a hypotenuse, which is across from that angle, that 90-degree angle of length C. The Pythagorean theorem tells us that a squared plus b squared is equal to c squared. We're going to use this to derive the distance formula. In this graph over here on the right, I've got 2 points, and I want to find the distance between those 2 points. So that distance is the distance there in green. So the distance that I want is really the length of the hypotenuse. I can go ahead and label these coordinates. So this first one, I'm just have them generically labeled as some random x, an x sub 1, and a y sub 1. And then the second point here has an x, a second x, we'll call that x sub 2, and its y coordinate is a y sub 2. I can put this into the Pythagorean theorem because between x1 and x2 is length a. So length a happens to be x2 minus x1. This equals a. The length b is the difference between these y values. So length b is equal to y2 minus y1. And from there I can find c. So for that distance formula, I need to take a squared plus b squared is equal to c squared. But I can rewrite this as x2 minus x1 squared plus y2 minus y1 squared equals c squared. If I take a square root on both sides, I get my distance formula. We go ahead and put the distance formula here. So the distance, c, but I'll go ahead and write it as d. So the distance is equal to the square root of the difference in the x's, x2 minus x1 squared, plus the difference in the y is y2 minus y1 squared. Let's use this formula to find the distance between the points 0, 3, and 4, 0. So if I'm looking for that distance, it's going to be the square root of the difference in my x's. So that's going to be 4 minus 0 squared plus the difference in my y's. Get those 2 underlined. So that's going to be 0 minus 3 squared. So just doing the math, I have a 4 squared, which is 16, and then a negative 3 squared, which is 9. This is the square root of 25, and we get a really nice distance for that value. That distance is 5. Okay, part B. So now let's go ahead and take a look at the distance between negative 1, 2, and negative 3, negative 3. So the distance is equal to the square root of the difference in my x's squared. So that's going to be negative 3 minus negative 1 squared plus the difference in my y's squared. Negative 3 minus 2 squared. Cleaning this up, I get negative 3. Those 2 negatives are going to become plus 1 squared. Plus, that's going to be a negative 5 squared. Okay, negative 3 plus 1, that's negative 2 squared, plus negative 5 squared is 25. So I get 4 plus 25, and we get the square root of 29. I could also put this into my calculator to get a decimal approximation, but I'm going to go ahead and leave this as radical 29. These are distances, so notice how I didn't put a plus or minus anywhere. Distances are never negative. They're always positive, or they could be 0. So never a negative distance there. Next, we want to define the circle, and we're going to define the circle as a conic section. The conic section, so this is a right cylindrical cone here. So this is, I'm just going to say a right cone. So the right cylindrical cone, you'll see that it takes two intersecting lines and rotates it. It's like having two ice cream cones tip to tip. So it looks like this. And I'm going to go ahead and cut through it to get a circle. I also have the ellipse here because if you took pre-calc with me, you've seen the equation for the ellipse. I'm going to go ahead and do a horizontally oriented ellipse. My center is at h comma k, so x minus h squared plus y minus k squared. Whoops, k squared. Let me clean that up a little bit. Okay, k squared, and the denominators are how far you've got to move in the x and y direction. So this is a squared all over b squared equals 1. So that's the ellipse. For the circle, so this was my a and my b here, a, and then this length here was b to get to those different vertices. On the circle though, for the circle, everything's symmetric. I don't have a different value that gets me to the circle from the center in the x direction and the y direction. They're just all the same, and they happen to be my radius r. So the equation for the circle actually looks really similar, but it's going to have an r squared in it instead of the a and the b. So here comes the circle. It's still x minus h squared plus y minus k squared. And instead of having those denominators, we're just going to write equals r squared. So this has radius r. So my radius is equal to r. And then the center of that circle is h comma k. In this first example, we want to find the equation of the circle with center 2, 3. This is my h comma k. And radius 4, so r is equal to 4. So as I'm putting this together in my equation, it's x minus h, so x minus 2 squared, plus y minus k, so y minus 3 squared is equal to 4 squared. You could write 4 squared there, or you could write 16. And that's all we need to do for that equation. Okay, next one. We want to find the equation of the circle with center 8, negative 4. This is my h and my k. That passes through negative 10, negative 10. This is just an x and a y. I don't know what r is. So r equals blank. Let's put this together in the equation, everything that we can put together anyway. So that's going to be x minus 8 quantity squared plus y minus negative 4, I'm going to write that as y plus 4 squared equals r squared. I don't know what r is, but I do know an x and a y. So I'm going to go ahead and replace those for the x and the y in my equation, and then I'll be able to solve for r. So going back to my blue pen, x is negative 10, so I get negative 10 minus 8 squared plus negative 10 plus 4 squared equals r squared. This is going to be negative 18 squared plus negative 10 plus 4, that's negative 6 squared equals r squared. And I'm going to go ahead and do 18 squared, or negative 18 squared is going to end up to be positive. So I just want 18 squared. And we get 324. Okay, so this is going to give me 324 plus 36 is equal to r squared. If I add those together, I get 360 equals r squared. It's actually all I need. I don't need to know what r is. R is the square root of that number. But actually, all I need for my equation is r squared, and that's going to go right here. Let me go ahead and write my final equation in green down here. So my final equation is going to be x minus 8 squared plus y plus 4 squared equals r squared, which is 360. Okay, next, number 3. So number 3 and number 4, so our last two questions, we want to find an equation. So we want to find a point in the first quadrant. So applying some of these concepts now. So we want to find a point in the first quadrant where the line with the equation y equals 0.5x plus 1 intersects the circle with radius 5 and center 1. So first of all, I'm in quadrant 1. So this is quadrant number 1, and then quadrant 2, quadrant 3, and quadrant 4. In quadrant 1, all of my x's are positive and my y's are positive. So if I end up with multiple answers, I want to choose the one where everything about my point, both coordinates, are positive. I've got one equation. I need a second equation to go ahead and work through and find the intersection. So I'm going to go ahead and put together an equation for my circle. So my circle is going to be x minus the x coordinate, which is 0. That's h. K is 1. Plus y minus 1 squared equals 5 squared. So my circle is x squared plus y minus 1 squared equals 25. I've got my line, and I can go ahead and put my line into y in this equation. So if I put that in for y, I'm going to go ahead and do my substitution here. So I get x squared plus parentheses y. Oh, and I want y there. So let me put this in red. Y comes next. Y is equal to 0.5 plus 1. So 0.5x, sorry. So 0.5x plus 1. And then I already had a minus 1 squared equals 25. Now I can solve for x. So let's go ahead and keep going. So I get x squared plus my 1's cancel. 0.5x squared is equal to 25. So this is x squared plus 0.5 squared. 5 squared is 25, but I need 2 decimal places. So this is going to be 0.25x squared is equal to 25. Adding those together, there's 1. So I get 1.25x squared equals 25. Divide both sides by 1.25. So x squared is equal to, let me grab my calculator. So it's 25 divided by 1.25. So 25 divided by 1.25, which is 20. So x squared is equal to 20. I want to take a square root. X squared, so x is equal to the square root of 20. I'm going to write that as 4 times 5. There would be a plus or minus on this, but remember I'm in quadrant 1. So there would be a plus or minus there, but I really just want the positive. So 20 is 4 times 5. So let's simplify that into x is equal to 2 square root of 5. Okay, so I've got my x coordinate. I still need my y coordinate. Let me go ahead and give myself a little more room. I'm going to erase these quadrants over here. And then let's go ahead and do step 2 and solve for y. So this is step number 1, my substitution. I'll go over here and do step number 2. And this is going to be to find y. I'm going to use the equation of my line because the equation of my line gives me a formula for y, 0.5x plus 1. I have my x value down here. So y is equal to 0.5x, which is 2 radical 5, plus 1. So I'm going to go 0.5 times 2, which is 1. So y is equal to radical 5 plus 1. So now I've got my y coordinate and my x coordinate, and I can go ahead and put those together in my answer. So my answer, my intersection, is 2 radical 5, comma, radical 5 plus 1. Okay, and there's that first solution. So it gives us some practice with radicals as well, gives us some practice with the algebra as we're solving for these intersection points. In the next example, it's actually really similar. I want to find the point in the first quadrant again. So I know that I want that point to be positive, positive. So I want a point in the first quadrant. Both coordinates then are going to be positive. And I'm going to intersect the equation 1.5x plus 2. I've got a circle with radius 5 and a center of 0, 2. Okay, so let's go ahead and go through this one. So let's put the first equation here. So y is equal to 1.5x plus 2. My circle, h is 0, k is 2. So it's going to be x minus 0 squared. I'm just going to write it as x squared plus parentheses y minus 2 squared equals r is 5, so equals 25. Next, I want to put my value for y into my next equation. This is going to be my substitution step. So substituting that in, I've got x squared plus, this is where my y goes. Y is 1.5x plus 2 minus a 2 squared equals 25. The 2's cancel, and I get x squared plus 1.5x quantity squared equals 25. So I can go ahead and do 1.5 squared, which I believe is 2.25, but let's double check. So 1.5 squared is 2.25. I'm going to write this as 1x squared plus 2.25x squared equals 25. Adding my coefficients together, I get 3.25x squared equals 25. Divide both sides by that 3.25. So again, I'll grab my calculator. And I want to do 25 divided by, so 25 divided by, that was a 3.25 on the bottom. And we get 7.692. We'll go ahead and call that 7.69. So I'm just going to approximate this one. So x squared is approximately 7.69. So x, I ignore the plus or minus. I'm going to go ahead and take a square root of this. So I'm going to go second square root, 7.69. And I get 2.77. So we'll call that 2.77. I'm approximating. Next, I want to find y. So this was step number 1. We found x. Step number 2, we're going to find y by putting it into our original equation, 1.5x plus 2. So y is equal to 1.5 times 2.77 plus 2. Let's grab that calculator again. And I'm going to go 1.5 times 2.77. Let me move that over a little bit. Times 2.77 plus 2. And then I'll hit enter. So y is equal to 6.155. So y is 6.155. So I've got my coordinates. These were not the nicest numbers, right? 2.77 comma 6.155. If I round that to 2 decimal places, we'll call that 6.16. A really great way to check this is by putting it right into Desmos. If you're not familiar with Desmos, that's okay. I'm going to step you right through it. I'm going to need both of those equations. So I'm just going to go back and forth between the two just a little bit. Let's go into Desmos. Okay, so Desmos. And I'm just going to put my equations in. So y is equal to 1.5x. I believe that was a plus 2. Let me just pull this off and make it a little bit smaller so I can see everything. There we go. Okay, yep, plus 2. And then let's go ahead and put the second one in here. And then this one is x squared. Just typing my equations in, I use the caret key right above the 6 to get the squared. And then I want parentheses y minus 2 squared. Again, with the caret key above the 6 squared. Did I forget a plus sign? Yes, I did. Okay, equals 25. So I'm looking for that intersection point in the first quadrant, and I see it right here. So if I go ahead and click on it, I see that I've got the right answer, 2.77 and 6.16. This is an excellent way to check your answers. So even though we haven't talked about any of the trigonometric functions in particular, we've started to talk about finding those distances. We've started to talk about the Pythagorean Theorem, and then also how we can work with our circles. And all of those are going to play an important part with our trig functions.